Assalamu alaikum. Good day everyone. I am Mehdi Hassan Choudhury from Kumilla University. My ID is 12008004. Today I am going to talk about different types of activation functions in neural networks, their uses, limitations and comparative performance. So, what are activation functions? Activation functions introduce non-linearity into neural networks, allowing them to approximate complex functions. Without them, a neural network would behave like a simple linear regression model, regardless of its depth. So, why activation functions are important? Because they enable neural networks to learn, integrate patterns, perform decision boundaries, and generalize across varied input data. Choosing the right activation function critically affects training dynamics, convergence speed, and final model accuracy. Here is the list of activation functions today we are going to talk about. These are sigmoid, tanh, ReLU, leaky ReLU, ELU, swish, and GELU. Let's first talk about sigmoid function. The sigmoid function squashes input between 0 and 1, making it useful for probability modeling. However, it suffers from vanishing gradient, leading to slow convergence and poor performance in deep networks. Then comes tanh. tanh scales inputs between -1 and 1, centering data, which improves convergence compared to sigmoid. Still, it shares the vanishing gradient problem, limiting its use in very deep architectures. ReLU, or rectified linear unit, is computationally efficient and solves the vanishing gradient problem for positive activations. Yet it can suffer from dying ReLU problem where a neuron becomes inactive. Then comes leaky ReLU. Leaky ReLU addresses ReLU's dying neuron issue by allowing a small non-zero gradient when inputs are negative, thereby keeping neurons active during training. Then ELU. Exponential linear units, or ELU, further improve learning by producing negative outputs that push the mean activation closer to 0, stabilizing learning rates. However, ELUs are computationally more expensive than ReLU. Then comes swish. Swish, proposed by Google researchers, blends sigmoid and linear functions. It adapts better to different architectures and often outperforms ReLU, though at a higher computational cost. GELU, commonly used in transformer models like BART, smoothly blends linear and nonlinear behaviors. It approximates the normal distribution and provides state-of-the-art performance in deep models. So here is a comparison table. In summary, sigmoid and tanh are outdated for deep networks due to vanishing gradients. ReLU remains the standard baseline for simplicity and speed. Leaky ReLU and ELU provide slight improvements in this case. Swish and GELU, while costlier, yield better performance in very deep models and modern architectures. In case of practical recommendations, for shallow to moderately deep models, ReLU is sufficient. For advanced models like transformers or very deep CNNs, GELU or swish is preferred despite the computational overhead. Okay, so in conclusion, we can say that activation functions must be chosen strategically, as trade-off exists between simplicity, performance, and training stability. So there is no universally best activation. It depends on the context and application to choose the right activation functions. And here comes the end of my presentation. Thank you for your attention.